OpenSesame. In this tutorial, we're going to take a look at how we can implement counterbalancing inside of our experiments. We're going to look at two particular examples, one in which we'll have two conditions that we want to counterbalance across participants, and a second example which will be a little bit more complex, where we'll have a look at how we can counterbalance across three or more conditions. So let's have a look at how we can implement a simple counterbalancing system inside of OpenSesame. Let's say that we want half our participants to receive the order block 1 followed by block 2, and the other half of participants to receive the order block 2 followed by block 1. A simple way of doing this is actually we can look at the subject number and see whether it's odd or whether it's even. If it's an odd number, we'll give them the order block 1 followed by block 2, and if it's an even number, we'll give them block 2 followed by block 1, ensuring that half our participants have one order and the other half have the other. To demonstrate this, I've got a simple experiment loaded up already. This experiment will display some instructions on the screen to the participant. It'll sit and wait for a space bar to be pressed before starting. We then have block number 1, which just contains one particular trial. I can show you. It's got one variable, MSG, and this one trial just puts the message block 1 onto the screen. We then have some second block instructions. So we'd normally say that's the end of block 1. Get ready for block 2, wait for the space bar to be pressed, and then we'll start block 2, and block 2 also has just one variable in it, MSG, with the message block 2. Then we have a goodbye message, say thanks to the participant, wait for a space bar, and then quit. So if I run this experiment right now, so I'll run it in a window with subject number 1. Like so. Here we have it with the instructions that go in there. We have block 1, instructions for the second block, and then we have block 2, and then the goodbye message, and that's the experiment. That's exactly the order we would want for odd number participants, but not for the even number participants. Now, a very crude way of sorting this out is that we could actually create a second version of the script and literally just move around the order of these two blocks. So we could put block 1 up here, and we could put block 1 down here, and that would create the opposite order for us. In the right place, that's better. It would create the opposite order for us, but then we'd have to remember to open up each particular script and make sure that we have the right script for the right participant and so on. It can get a little bit out of hand, that, and it's much more simple to let OpenSesame take care of this for us. And we can actually make use of a variable that's built inside of OpenSesame called subject parity. So open up the show variable inspector window, and you can see it down here, subject parity. It takes two values, odd if the participant number was odd, and even if it was an even numbered participant. And we can actually use this as one of the conditions for running a particular block. So if we have a look in the main experiment sequence at the moment, let's put these back in the right order. Right around like so. At the moment, we always run every single object inside of the experiment. So we always run the instructions, we always run the space response, then we always run block 1, second block instructions, and so on. What we can actually do is specify that we only want certain blocks to run depending upon a certain condition, i.e. that condition has been met. And what we can basically do is tell OpenSesame only run a block if the subject parity is even or if the subject parity is odd. So what we can do is if we add in a second copy of block 1 and a second copy of block 2, they appear down here at the bottom. I'll put them together in two pairs. So that now the experiment is ordered instructions followed by block 1 and block 2, then the second block instructions followed by block 1 and block 2, which essentially just give us the same order done over twice. We can specify certain conditions about whether we want to run that particular block. And what we can say here is run this block 1 here if the subject parity is odd, i.e. it's an odd numbered participant, and run this block 2 here only if the subject parity was even, so it's an even numbered participant. We can flip that over in the second pairing and say run this block 1 here only if the participant parity was even, and then run this block 2 here if the subject parity was odd. And the way we do that is we put that into the condition box over here. And remember, subject parity is a variable, so we need to specify it inside of the square brackets. So I can just type in subject parity So first time up here, it's going to, if you've got an odd number participant, it's going to run block 1 and ignore block 2. So if I come down here and flip those two over, so that for even number participants they get block 2 followed by block 1. So I then need to say subject parity equals even. And then for the second copy of block 2, I need to say subject parity equals odd. So just to walk our way through this, if we've got an odd number participant, we'll have some instructions on the screen. We'll come down to block 1. Because we've got an odd numbered participant, it will run block 1. However, it won't run block 2 because it will only run that if we've got an even numbered participant. So this is going to be skipped. We'll get the second block instructions. Then we'll get block 1 won't be run because we've got an odd number participant, but block 2 will be run because the subject parity is odd. If you imagine now we've got participant number 2, we'd have instructions followed by block 1 being ignored because we've got an even number participant, and this is only going to be run if the subject parity is odd. However, block 2 will be run because the subject parity is even. So let's do a quick demonstration of that. I'll say subject number 1. So this should give us the order block 1 followed by block 2, and we get block 1 instructions, second block, block 2, and goodbye. I'll try running it now with subject number 2, which should give us the opposite order of the blocks. And so there's the instructions. We now get block 2 first. There's the instructions for the second block, and now we get block 1, followed by the goodbye message. So that gives us a nice simple way of implementing a simple counterbalancing system inside of OpenSesame. Sometimes we want to implement a more complex counterbalancing system. Let's say, for example, if we have 3 blocks that we want to counterbalance across participants, maybe perhaps using reduced Latin square design. That would be that participant number 1 gets the block order 1, 2, 3. Participant number 2 will get the order 2, 3, 1. And participant number 3 will get the block order 3, 1, 2. For participant number 4, the sequence will reset, so they get the sequence 1, 2, 3. Now, because we've got more than 2 blocks here, we can't use the subject parity variable to help us out. After all, subject parity could only contain 2 values, odd or even. That works fine if we've only got 2 block orders, but now we have 3 block orders to worry about, so we have to use something slightly different to determine what that block order is going to be. To determine that block order, we'll actually use a bit of arithmetic, namely the modulo function. I'll do a demonstration of this using the debug window, because that lets me type some Python code in directly. Modular arithmetic basically is, you can think of it like the remainder from a division. So if we have, say, 3 modulo 3, it's like saying 3 divided by 3 is 1, remainder 0. If we had 1 divided by 3, it would be 0, remainder 1. In this particular case, the result of 1 modulo 3 would be that remainder value, the 1. In the case of 2 divided by 3, or 2 modulo 3, it would be 2 as the remainder, and that's what we return to us. If we use 4, for example, 4 divided by 3 would be 1, remainder 1, so the modulo function would give us the return of 1 there for the remainder. As you can see, we actually end up with 3 numbers that basically come out of this modulo division. We either get 0 when it's a multiple of 3, we get 1 in the case of 1 modulo 3, or we get 2 in the case of 2 modulo 3. And we can use these 3 values to determine which block order we want to give the participant. Now in Python, the modulo function is defined by the percentage symbol. So do the demonstration down here of 1 modulo 3 gives us the answer 1, because that's 1 modulo 3 is, well, it's like the 1 divided by 3, which would be 0, remainder 1. We can use 2 modulo 3 gives the result 2, and 3 modulo 3 gives us 0. If I put 4 in, we're back at 1 again. So we've got this sort of cycle we've got here going 1, 2, 0, 1, 2, 0, 1, 2, 0 for all the possible participant numbers that we've got. And we can actually exploit this to determine what our block order is going to be in our experiment. So let's have a look at how we can actually implement this inside of OpenSesame. execute that. I've got a simple experiment opened up already, which contains this first thing in here is a inline script object, which I'll open up. And it contains this bit of Python code in here. It takes the form of an if, else statement. And basically what we're doing here is looking for these certain conditions to be met. So we're saying if self-get subject number modulo 3 equals 1, then if it does indeed equal 1, B1 should be set to 0, B2 should be set to 1, and B3 should be set to 2. We'll talk a little bit about this B1, B2, and B3 in a moment. First of all, let's just focus on this bit up here to see what that actually means. Subject number is a variable, just like things like subject parity was in the simple example. But in the actual inline script object, we can't just stick subject number inside of those square brackets. Instead, what we have to do is use this bit of code here, this function, that basically means this experiment, then go and get the variable called subject number. That will return the number of the subject number. We then perform the modular arithmetic on it, and we'll see what the outcome is, and does it equal 1. If it does equal 1, then we set the values as we set up here. However, if it does not equal 1, let's say for example the subject number was 2, 2 modulo 3 as we saw earlier on is actually 2, we'd actually come down to this next statement, which is else if, doing the same bit of arithmetic here, except this time does it equal 2. In the case of subject number 2, yes it will do, so B1 will equal 2, B2 will equal 0, and B3 will equal 1. There's only one other option, so I haven't put an else if in, I've just simply said else if these two conditions, so this condition here and this condition here, are not true, i.e. the result out of the modular division is not 1 or 2, then just set B1 to 1, B2 to 2, and B3 to 0. This will happen in cases where the subject number is a multiple of 3. So let's have a look at what this B1, B2, and B3 actually mean. You might have guessed they stand for block 1, block 2, and block 3. The 0, 1, 2 that these values are being set to actually indicate which order we're running the block, or more precisely, which block is run first. In all three cases, whichever gets set the value as 0 will be the first block run. So in the case of a subject number 1 or 4 or 7 and so on, the first block to be run will be B1. For subject number 2, the first block that will be run is B2. And for subject number 3, the first block that will be run will be block 3. Then the 1 indicates the second block, and then the 2 indicates the third block that's going to be run. The reason we use 0, 1, 2 here, by the way, and not 1, 2, 3, will become a bit clearer a little later on. Then we also have to set these values to be experiment-wide, because otherwise we'd only have access to these in inline scripts. And actually what we want to do is access these particular values, this B1, B2 and B3, from outside of an inline script. The reason for doing this means that we only need to have one inline script in order to do this counterbalancing. So to make them across the experiment, available across the experiment, we have to say experiment or exp set the variable B1 to the value B1 that we've defined up here, and the value B2 to B2, and the value B3 to B3. So that just makes sure that these values are available experiment-wide. So just to briefly recap this particular screen, if we run this script and the subject number is number 1, the very first condition up here will be satisfied, so subject number modulo 3 it will indeed equal 1, so we'll set B1 to 0, B2 to 1 and B3 to 2. However, if we have the subject number 2, it won't be the first condition that's satisfied, it will actually be the second condition, so that will be subject number, i.e. 2, modulo 3 will indeed equal 2, in which case we'll set B1 to 2, B2 to 0 and B3 to 1. But in all other cases, basically where the subject number modulo 3 is actually going to equal 0, then B1 will be set to 1, B2 will be set to 2 and B3 will be set to 0. And then finally we just make sure that these variables are available across the entire experiment. So let's take a look at what the rest of this experiment is going to be doing. After we've determined what the block order is going to be for our participants, we have some instructions that will be displayed upon the screen to the participants, and then we'll sit there and wait for them to press the space bar to actually get started. We then have this loop object called main loop. It doesn't seem to contain very much. All it really is just 3 cycles with no variables set in it. And the reason it's been set up this way is what we want to happen is to run through 3 particular blocks of the experiment. It doesn't matter which order we're going in at the moment, we just have 3 blocks that we want to run. So you can consider main loop to be sort of the control block, the one that's going to control these 3 particular cycles of the experiment. And so by setting the block up this way, it's going to run this sequence called main sequence 3 times. I click on main sequence now, and you can see we've got 3 blocks inside of the experiment, block 1, block 2, and block 3. These are set up just to display a simple message on the screen. So we have this one variable called MSG, which is block 1 for block 1. It says block 2 for block 2, and for block 3 it says block 3. All 3 blocks run the same trial sequence, which displays this text render display on the screen that says this is MSG, in which case that would say this is block 1, block 2, or block 3. Towards the end of the experiment, we have a goodbye message, and after we've presented that goodbye message, we want the computer to wait for the spacebar to be pressed before we actually finish. Before explaining how we actually implement the counterbalancing, to make this nice and clear, let's just have a look at what happens if we run this study right now. We have main loop, which contains 3 cycles, so it's going to call main sequence 3 times. Main sequence contains 3 blocks, block 1, block 2, block 3, each of which are going to display a message on the screen that says this is block 1, this is block 2, and this is block 3, respectively. So what we should see is some instructions come up on the screen, followed by the message, this is block 1, this is block 2, this is block 3, as it runs through main sequence for the first time. Then, because we're running through main loop 3 times, we'll actually get this is block 1, this is block 2, this is block 3 for a second time. And then we'll get it a third time because we're running through this loop 3 times. So it'll be this is block 1, this is block 2, this is block 3, the third time. So what we're going to see is basically messages for 9 blocks will appear on the screen. Then we get our goodbye message, and we'll sit and wait for the spacebar to be pressed. So I'll quickly just run this right now, just to demonstrate what we actually get. So there's our instructions. So this is the block 1, the first time around we've been through that main loop. Block 2, block 3. Then we get block 1 again, followed by block 2, followed by block 3. And thirdly, block 1, block 2, and block 3, followed by the goodbye message. The next thing we need to do, though, is to prevent block 1, block 2, and block 3 always running on every particular sequence. What we basically want to do is change the values on the right-hand side that say run if, where they're currently set to always, which is the default. We want to put some condition in there that says only run block 1 if certain conditions are met, only run block 2 if certain conditions are met, and only run block 3 if certain conditions are met. This is the reason now, coming back to what we talked about at the beginning, about why we use the values 0, 1, and 2 for setting our block order. The reason is this particular sequence called main sequence. Every time it's run, there is a variable that's called count main sequence. I'll show you that in the variable inspector. Space for it. So it's over here. Count main sequence. This value will increment every time main sequence is run. Now the thing is that the very first time it runs main sequence, count main sequence will have the value 0. The second time we run it, it will have the value 1, and the third time we run it, it will have the value 2. This is the reason we use these numbers 0, 1, 2, and not the numbers 1, 2, and 3. So what we want to basically say to OpenSesame is that if count main sequence is 0, we need to look at what particular block order we've got, and then run that block if indeed we should be running it for that particular counterbalancing sequence. Now we don't actually have to use any more inline code here. We can actually use this run if condition box here and actually put some Python code in directly. If you're going to put Python code in directly, you need to remember to put the equal sign at the start of the condition. I've actually got the condition we're going to put in a separate text file, so it's easier to display on the screen. We have the equals sign, and just worry about this one up here at the moment because this is the one we're going to use for block 1. Equal sign, so it indicates to OpenSesame where you're going to use some Python code in here. We're then going to get the value of B1 that we set earlier on, and we're going to see if that's equal to the value of count main sequence. It's probably easier to explain this one with a concrete example. If we go back to the determine block loop and or block order, and we consider the case where we've got the subject number 1, B1 is going to be set to 0. This means, if we go back to our inline script that we're going to have, whenever B1 has been set to 0 and count main sequence is also 0, then we want to run that particular block. In the case of B2, for example, on the first time round we run through the sequence and count main sequence is set to 0, well, B2 is actually set to 1, so this condition will not be met. And likewise, this one here for block 3, count main sequence, when that is 0, is actually set to 2 for this participant here, so it won't be run on that particular loop through the main sequence. However, on the second time through we go through the sequence, count main sequence will now take the value 1. That will basically mean then that the self get B1, which is going to evaluate to 0, and self get count main sequence, which will evaluate to 1, will no longer be true. So block 1 won't run. However, if we look at self get B2, B2 has been set to 1, and our count main sequence on the second time through is indeed going to be the value 1. So this condition here will be satisfied and this block will run. And then look at the third example here. Self get B3, which has been set to 2, does it equal the count main sequence, which on the second time through is 1? The answer is no, so this block here will not be run. Then the final time we run through, we'll be getting the value of B1, which will be 0 again, but this time count main sequence will be 2. It's always incrementing every time we go through the sequence. B2, which is set to 1, will not equal 2 either. However, B3, which has been set to 2, will equal the count of the main sequence, so that block will be run. The result of this is that every time we go through that main sequence, only one of the blocks is going to be run, and the other two are not. They're going to be skipped over because the value that we've set in here does not equal the main sequence. So just to clarify, the reason we use these 0, 1 and 2 is we're actually referring to this value here for count main sequence. That's why we're using those and not 1, 2 or 3. So what I'll do is I'll copy and paste these into the main sequence. Variable inspector. Paste that in. Go back and get the next one. Get the last one. That in. So these blocks are only going to run if these conditions have actually been satisfied, i.e. the result of this particular comparison is true. So in the first time round we run for participant number 1, block 1, which is being set, or B1, it's been set to 0, will indeed equal the main sequence count, because the first time round is 0, but it won't satisfy block 2 because B2 has been set to 1, which is not the same value as 0, which is the count main sequence. The same thing goes for block 3. So the first time we run through, only that one block is going to be run, block 1. Second time we run through, when count main sequence has changed, it's now the value of 1, that's going to equal the value B2. So block 2 will run and the other two won't. And then finally, the third time we run through, B3, which was set to the value 2, will then equal the count main sequence, which was also now set to 2 on the third time through the loop. So let's just try running this and see what happens. So use the subject number 1. So this should give us the instructions followed by this is block 1, this is block 2, this is block 3. We then should have the goodbye message. So let's see what we get. There's the instructions. This is block 1, this is block 2, this is block 3, and then the goodbye message. Let's try it if we run participant number 2. Remember, participant number 2 should have the sequence 2, 3, and then block 1 to finish off. So they get that, so there's the instructions, and then they get this is block 2, this is block 3, and this is block 1, followed by the goodbye message. And to finish it off, we'll run it with participant number 3. 3, 1 and 2, and 3, 1, and then block 2 to finish off with the goodbye message. So say no. So that's how we can implement some more complex counterbalancing inside of OpenSesame using minimal amounts of inline Python code. It may seem a little complicated to get your head around it the first time you start looking at it, but essentially what we're just doing here is using some of the inbuilt variables that are inside of OpenSesame. In this particular example, it is this count main sequence that we're actually exploiting to see, okay, which cycle through the sequence are we, and which block should be running on that particular sequence. And that particular value is determined in the inline script depending upon the subject number. So hopefully that gets you started on thinking about how you use these more complicated examples inside of your experiments.